Good afternoon and welcome to today's webinar, Understanding and Implementation of Machine Safeguarding Standards, presented by EHS Today, New Equipment Digest, and Machine Design. Today's webinar is sponsored by Schmersal. My name is Sandy Smith and I'm Editor-in-Chief of EHS Today. Before we begin, I'll explain how you can participate in today's presentation. If you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the Help button below the slides. We welcome your questions during today's event. Just type your question into the question window on the side of your screen and then hit the Submit button. We will answer as many questions as possible during the Q&A session that will follow the main presentation, and please feel free to send in your questions at any time during the presentation. Please also be aware that today's session is being recorded and will be available on the EHS Today, Machine Design, and New Equipment Digest websites within the next week. You'll be notified by email when the archive is available. And now let me introduce today's speaker. Mike Durocher is a TÜV-certified functional safety engineer for machinery. His 20 years of experience include controls engineering to design, build, and integrate full machine control systems. His safety experience led him to help corporations develop corporate safety standards, perform machine safeguarding risk assessments, machine safety training and design, as well as implementation of safety systems for all aspects of machinery: electrical, electronic, pneumatic, hydraulic, and mechanical. Now, let me turn things over to our presenter, Mike. The floor is yours.
Thank you very much, Sandy. Good day, everybody. We appreciate your time in joining us and paying attention to our webinar on understanding and implementation of machine safeguarding standards. And what we're going to do over the course of the next 45 minutes or so here is looking at some of the common challenges with machine safeguarding, because many times machine safeguarding ends up being extremely difficult from the start to the finish and trying to implement something. And most of the time, it all stems from the starting of the process and understanding the standards that you're using or need to use, how they're written, but also the challenges faced with getting the standards implemented into your facility and onto your machines. So the first thing we're going to look at this afternoon and this morning are some of the common challenges. And what we typically see are four primary areas in challenges when it relates to machine safeguarding. The first one being personnel, the people that you're working with, whether it be EH&S personnel, operators, maintenance, engineering techs, the engineers themselves, project engineers. Who's really involved or who needs to be involved, and what do you deal with when you're dealing with the human factor when it comes to machine safety? What the impact is on productivity. A lot of people see the safeguarding or the addition of safeguarding on existing equipment as a major impact on productivity, and there's some misconceptions revolved around that. The next one we'll look at is the cost factor, what the assumption is when it comes to cost and how much safety really costs on the machine and some of the common arguments for that. But then finishing off with the right solution. There could be multiple ways of safeguarding equipment or machinery, and it's a matter of finding the right way, not jumping into something and just throwing a Band-Aid on the machine. It ends up costing you more money and not getting the right solution, and you set yourself up to fail. Going through and finding the right solution based off the arguments you get from that. So in the very first one we're going to look at is the personnel factor. And what we did here is we put some of the most common quotes you tend to see and the categories they really fall under. The defensive walls are put up, and what we mean by that is human nature definitely kicks in everything that we do. And the same thing occurs when we talk machine safeguarding. Automatically, when you start looking at a machine and you're going to make changes or modification or retrofits, that the envision factor from an operator or maintenance standpoint is you're going to make their job harder. And the defensive walls do get put up. They put up blocks. They come up with reasons why the machine shouldn't or could not be properly safeguarded. So when you look at some of the most common arguments, and I'm sure everybody's heard some of these at some point in their career when they're talking machine safety, the first one, it'll never happen to me. No matter how you look at it, nobody ever wants to see anybody get hurt. But the whole it'll never happen to me syndrome becomes a problem because it never has happened to them doesn't mean it will never happen to them. Just because they know it and maybe they feel that they're protected, the goal is to protect them as well as other people that may work on that equipment. So they may have worked on that equipment 3 months. They may have worked on that equipment 18 years and never seen anything happen as far as a serious injury on the equipment. When you do your risk assessment, it doesn't mean that nothing will never happen to it. It could be something that they get distracted. It's an accident. It wasn't something that was intentional. And a lot of times as people, human nature, as I mentioned, kicks in, and we tend to take on a little bit more risk when we're talking about ourselves versus looking out for somebody else. And that syndrome that'll never happen to me, I know how to use this equipment, a lot of times that might be the person that ends up getting hurt and then they become a statistic. We don't want to see statistics. We want to avoid becoming part of that list. So when you look at it, you want to look at that you're not just protecting them, you're protecting other people, but we want to find ways to work with you to provide that protection and allow you to still do your job. The next one, you're going to make my job harder. Well, as soon as they see that you're going to throw something up in their way where they always had open access to, that initial impression is you're going to make my job harder because you put a wall up. You put a Lexan barrier, you put a fence or a guard. I can't access that machine the way I used to. They become part of the process in finding a solution where you really want to dig into what they're doing and what they need access to see what's really going on in the machine that they need that access and how to actually tie your circuitry in properly to allow the machine to shut down but be able to restart and pick up right where they left off so they're not exposed to a hazardous situation. The last one in the defensive side is common sense tells me not to do that. You'd be amazed, and I'm sure many of you can readily admit that you've either said it yourself or you heard somebody say, if they're stupid enough to stick their hand in there, they won't do it again because they're going to get bit. You can look at it and see that it's a hazard. Why am I going to put myself into a dangerous situation and cause severe harm to myself? That doesn't make sense. Self-preservation should kick in and keep me from doing that, so we shouldn't need to guard it because I'm never going to do that. Reality is, most of the time self-preservation does kick in. I'm not going to say that people don't intentionally do it. It's not something that I've experienced personally that I've seen intentional, but we've definitely seen and experienced and been part of investigations after accidents have occurred on the machine. It wasn't something they intentionally went and did, whether it was something that they got distracted, they did something that they weren't supposed to, they want to admit, yeah, I never should have done it that way. Reality is they did. So putting in certain design measures are challenges to overcome. You take away that common sense factor because we don't want people just relying on common sense alone and have somebody get hurt. There's things that you can do to not even let it get that far to keep people from serious harm. Another consideration is these are some of the operators that think with some of these comments, but we have to take into account maintenance and engineering. You can't just think of the operator. Maintenance and engineering have to do certain things on a machine that they may be authorized to do with running the machine without a guard, whether it's in a bypass mode or in a troubleshooting mode or a setup mode. there's certain things that they may need to get access. And the very common thing is, okay, you can put a guard up. I don't have a problem with that, but I need to bypass the guard to be able to do my job. Understand what they really need to bypass, and if bypassing is really something they do need to do, because when you kind of drill down to what their function is and what they need to do, many times you may find out it's more of what they're used to. It might be more of a convenience factor so they don't have to constantly open and close the doors. Well, you look through the tasks that they have to do, figure out what is the proper solution for them, because sometimes it might be, yes, closing the guard again makes more sense to keep them protected. Other times it may be giving them an additional measure such as doing two-hand control to allow that guard door to open, because a two-hand control is an acceptable form of safeguarding in that maintenance operation when you look at your risk analysis that you do on the machine. So you're going to work through the solutions. You don't want to take the approach that, yes, we got to put a box around this, because you may be setting yourself up to fail and give safety of the machine a black eye that people don't buy into it or believe in it because they prove that it doesn't work. It's really figuring out what's going on in the machine. What are the hazards? What are some of the best methodologies out there to implement a solution to that hazard? Safety professionals. You have EHS professionals that they understand the concepts of guarding. They don't understand the nuances of the controls and the wiring and maybe all the different aspects out there. They have a very broad workload on their backs as well, because it's not just machine safety. It could be chemical storage, aisleways, electrical, hazmat, hazcom. There's a lot of different aspects to EH&S, and one of those is not knowing how the machines really run. So you get into that situation where EHS may look at it and say, there's a hazard, you have to put a box around it, and needs to be guarded. Well, that's not necessarily the correct approach either. It has to be an open dialogue to figure out how the machine works and what is the best solution, not just say it has to be guarded. Okay, it has to be guarded, but what are some of the ways to guard that can minimize the impact on any production, keep things rolling, but improve the safety integrity of the machine and the controls that is allowing that machine to stop. Management, when you look at a management perspective, whether you want to, I hate to use the term bean counters, sometimes you got management that's not seeing what's going on the floor and the cost factors associated with it, because at the end of the day, as a company, our goal is to produce parts. We have to get so many widgets out a day and be a profit center to the owner, the stockholders, whatever the case may be in the situation that you're in, and minimize cost impacts. But if the solution that gets put onto a machine cuts production in half, management's going to look at it, was this really the right thing to do? Did we look at this? And they see it as an impedance, because all of a sudden the profitability went down, the cost factors went way up. So looking at that balance of what really needs to be done. The next one we're going to look at is the productivity aspect. The two most common ones, the machine's going to run slower due to the steps needed, or I cannot work with the machine in the same way because you put these guards up in my way now. One of the best things you can ever do to understand what they're talking about and why these statements are being made is understand what's going on with the machine itself. Why is the machine going to run slower? Why is this going to be in the operator's way? When you start really grilling down versus just making bold statements and must be guarded, and this is the feedback that you're getting of why it can't be guarded, you have to look at the function of the machine. It's easy to say something has to be guarded, but if you're not understanding the function and what the machine was supposed to do, was it designed to do the task that it's doing? It might be the age of the machine. Maybe there is something wrong with the machine that never got reported to maintenance. or if it did, it never got fixed. It wasn't high on the priority list. So what you're finding is operators need to have more hands-on intervention of the machine, because something as simple as a jam and opening and closing doors that have safety switch on it that shuts the machine down gets in their way, because now they're shutting the machine down where before they were interfacing when the machine was running. Not the right thing to do, but in the case like that, you install a guard, what happens is it does impact the productivity of the machine, but it's not the safeguarding that really had the impact on the machine. It has to do with the function of the machine. Why is this happening? Why is this jamming all the time? Is there something mechanically wrong where maybe a part has worn and there's some slipping going on and there's jamming going on in that particular area that's a hazard area, but they have to constantly get in there and clear it out? What you find is when you go through the risk analysis and you start coming up with solutions, you have to look at the function of the machine and what's happening and what the operator or maintenance are doing to those machines to figure out, why is this going to be an issue? Let's fix the inherent problem with the machine, because when we're able to do that, now we can apply effective safeguarding. You may even have an impact it as an improvement in productivity, because you're able to solve some of the issues that kind of went masked by how an operator works with the machine. Bottom line is, on any machine, you could have designed every nut, bolt, wire, valve, hose, piece of metal in that machine. You turn that over to an operator, odds are within 9 to 12 months, that operator will know that machine better than you. They'll know every little quirk, every little nuance of that machine, and where they think it's a normal routine running, that's how they have to run the machine. It might be something that needs a different design, or it needs an improvement in productivity to have an effective guarding solution. So it is important to really understand the function of the machine and what's going on and what kind of interfacing they need, because if you just throw a box up, it might be the design of the door or where they need to access, that if you don't figure out what they need to do and what's important to them and take that in consideration, you're not going to have an effective guarding solution. Doesn't matter what any of the standards say. Doesn't matter from this point on. If you don't get on the same page and understand that, you're going to have an uphill battle on effective machine safeguarding. Next one that always comes into it is a cost factor. Whenever you do machine upgrades on an existing machine, doing these mods are going to cost too much money. Or the safety upgrades are going to cost more than what the machine is worth. Some of the times that might be true, but you have to find out what is the truth in that and what are the guarding solutions. Because you can have a lower cost guarding solution that's quick, cut and dry, a box with a guard door and an interlock with the circuitry behind it, and minimize the cost impact, but it might not be an effective solution where having additional control measures or changing it from a swing door to a counterbalance door because of spacing, it solves an ergonomic issue, but there's a higher cost factor to that. You really have to look at each solution as an individual basis to figure out what is the right solution and what is the true cost factors associated with the guarding. The safety upgrade costs more than the machines. You see that on, sometimes the simplest machines, such as a drill press or a bandsaw. You might have paid a couple $100 out of Sears or MSC or something like that, and then when you have to put all the proper guarding on it, all the guarding costs more than the machine. Once it hits the industrial floor, it falls under government regulations to protect operators from serious harm, and putting some of those measures in place, you shouldn't look at the cost factor of the machine when you buy it. You should look at the cost factor of the machine plus the safety as your capital expenditure as one whole machine, so you can have it properly safeguarded. The cost factor, sometimes it's more of an insurance factor. Why do you have insurance on things? It's in case of a loss. Well, when we talk people, we don't want to get to that loss and see somebody lose a finger, hand, or a fatality. You put the protective measures, it costs money, and invest in the safety of the people that are employed for you to offer proper protection, because the same thing as I said earlier, you don't want them to become a statistic, and your cost factor is going to be a whole lot more if that does happen versus what the guard would have cost to begin with. When you factor in lost work time, workman's comp insurance rates, lawsuits, things of that nature, those costs add up extremely quick. OSHA fines. OSHA has a tool on their website called Safety Pays, where you can plug in some data and look at what the true cost is on an estimated value for direct and indirect costs resulting in certain types of injuries. And those cost factors become justified real easy, that when you look at the bigger picture, yes, there is a cost to safety, but it can cost you a whole lot more if somebody were to get hurt because you decided not to implement proper safety on a machine. The last section is finding the right solution. And some of the things you get into is the arguments that that'll never work, which kind of relates to going back to putting the defensive walls up. If somebody is stubborn in the fact that it doesn't matter what idea you come up with, that'll never work. I don't know what standards to use. I don't know what they're telling me. I see words, but how do I actually apply it to a machine? Finding the balance. You get one person that says we can't guard the machine. You have another person that says you have to guard the machine. They're on opposite ends of the spectrum. You have to find that balance and communicate with one another. The argument that'll never work. Sometimes it's because the ideas didn't come from the people that are really working with the machine. And if you force something into them, they may find every way of not allowing it to work. But when they become part of the solution, there tends to be a vested interest in that, where they're going to help make that solution work because they understand that you're out there to try to protect them. You do not want to see them get hurt. EHS is not the enemy of production. They want to see people go home at the end of the day, be able to go home to their families without any injuries, going to the hospital, and that's what your goal is. So getting through that argument that will never work, you got to break down the barriers. You got to start looking at it. When you start looking at the solutions, there isn't a magic bullet that one solution fits all. Every machine is going to be individual on what's being run, how it's being used. And you may not just have one solution. There might be 3, 4, 10 different solutions when it comes to machine guarding that you can effectively apply. Work together as a team. What are some of those solutions? What are some of those design considerations in guards or barriers or doors or light curtains or two-hand control? What are some of the most effective ways that it will minimize the impact and you get the buy-in from the people that are going to be using it? That's really what you want to get to when you find the right solution. Looking at the standards, in the next several slides, we're going to look at some of the standards and teach you hopefully how to interpret some of the words that are in there and some of the commonalities between those on a more of a generic basis. With the balance, we can't guard it, you have to guard it. It's the typical productivity versus safety battle of going back and forth that you have to do it, I can't do it. It's the same thing. You have to get to where that middle of the line is. Understanding the equipment. EHS needs to understand how the equipment runs, how the operator is using it, but the flip side is true as well. Production, engineers, maintenance, they need to understand that it's not EHS just coming down here saying you have to guard it, and they don't have an understanding of why, what's really needed, what are the hazards. Make sure they're educated on what machine safety is, why you're protecting them, and they understand what the solutions are and how they work. That way you can work together as a team break down the barriers, and move on. Which leads me into the next slide, communication. Before you start any safety project, before you start integrating solutions, when we started this webinar, the big issue is we find that machine guarding can tend to be very difficult finding the right solution. And the start of that is the communication factor. If you're not communicating as a team, it is an uphill battle. Forget anything else related to machine safeguarding. If you're not communicating as a team, if you don't take those barriers down and educate each other on what's going on with the machine and what are the needs and the requirements are, nothing's going to be able to move forward effectively for you. You can force solutions down people's throat. It's going to create animosity, and you got to get over that hurdle. You got to get people on the same page. You got to get them talking the same language. Again, you're working as a team. You want to understand how the machine operates on all parties. What needs to be done on that machine? What is the function? What are some of the problems that you're experiencing that you can take into account on what the needs are? It's not just the operators that we mentioned. It's maintenance. Maintenance, it might be an older machine. Well, there might be lubrication points on that machine that maintenance has to gain access to. But hey, great, you guarded the machine, you protected the operator, but you just made maintenance's job a whole lot harder because you guarded all the Zerk fittings on the machine to keep them from effectively performing PMs on the equipment. What are some of the solutions that you accommodate? Because you don't want them to start removing guarding. One of two things are going to happen. Downtime is going to either increase or it's just not going to get done. If you provide access holes in the guarding where there is no reach to the hazards, but they can get to those Zerk fittings to perform the proper PM. Or maybe bring them all out to a lubrication manifold where now they're hitting it with one point. You made their job easier. You made the PM a lot quicker, and it becomes more efficient because of the guarding solution put into place. So it's looking at everybody involved and understanding how the machine operates and what are the needs for that machine and the safety of that machine. But safety is not just covering the hazards. It's looking at the operation and coming up with a good solution that'll work for everybody. Once you have that, you can now put the pieces together. You can start working with EHS, production, maintenance, engineering, whether it's using third-party integrators or you have your own internal resources to do it. You can now start putting the pieces together and coming up with a game plan and coming up with good solutions and designs for machine safeguarding. So everything we've talked about in the last half hour really has to deal with getting on the same page and communicating. If you can do that, you're over the biggest hurdle when it comes to machine safeguarding, because now everybody understands, everybody's on the same page, everybody knows what the goals are and how to actually achieve those goals to come up with a good working solution. When you come up with a good working solution, the machine is running well, the safeguarding is effective, and you go for your goal of achieving a safe work environment and protecting people from serious harm. That's what we want to do at the end of the day. Now that you've got that communication factor going, the next thing comes to the standards. We start seeing all these standards out there. We have OSHA regulations. We have ISO standards. We have NFPA, ANSI. Sometimes all these different standards can get very confusing. Which ones do I need to go with? What are my guides? Where do I go to figure out what I need to do? Hopefully we can simplify that a little for you and break it down. The first thing when it comes to priorities is the governing bodies, whether it's the Ministry of Labor up in Ontario or OSHA in the U.S. You got more of the CE directives over in Europe. But if I simplify it, just talking about OSHA, for example, as it relates to machine guarding, there are specific OSHA standards, 29 CFR 1910.212 for machine guarding. OSHA is our governing body in the United States. You have that in other countries around the world. The governing bodies are the priority. So your first point is going to your governing body, being, in this case, in the U.S., being OSHA. There are some specific OSHA standards related to machinery. It could be 1910.147 for the control of hazardous energy, which is lockout, tagout principles and practices and procedures. 1910.212 has to deal with general requirements for machines. Unfortunately, what happens is they're a governing body, but some of those standards are very generic, and it's hard because they're so generic that what do we do? How do we read those, interpret them? Where do we go from there? Well, once you implement what you can on the OSHA guidelines, the next is the voluntary industry consensus standards, because a lot of these standards are not incorporated by reference into law by the governing bodies, but the governing bodies will also refer you back to industry consensus standards, letting you know that they won't override an existing standard, an existing governing body standard, but they can be used in conjunction with these standards to improve the overall safety of the machine. When the industry comes together for specific types of standards, what we're talking about is ANSI, ISO, NFPA, IEC, could be ASME. There's different standard organizations out there when it relates to these different things. You see some examples there on the slide, such as ISO 12100, which is the risk analysis standard, B11.19 for machine tools, safeguarding requirements for machine tools, NFPA 79, industrial controls, 13849 for ISO for controls and safety performance level criteria. Specific ones such as B65.1 for printing presses, for example. When we start breaking those down, one thing to understand is standards are broken into types. We have type A, B, and C standards. You can read what's on the slide there. Type A is basic general principles across the board, across all machines, and a general concept. So ISO 12100, for example, where you're talking general requirements of risk analysis and hazards that are associated with equipment. It's not equipment specific. It's not specific to a group. It's a type A standard giving you general concepts. It applies to all machines. Type B is specific to a group, and they're broken into two types, B1 and B2, where B1 is particular aspects to a machine, or B2 being aspects to safeguarding materials such as interlock switches or light curtains. They're specific to a type of device. Examples of B1 type of standards would be ISO 13849 for performance levels. It's not specific to a machine, but it's specific to a group because it's performance level for the safety-related part of a control system. NFPA 79 is a type B standard. It's specific to industrial controls, not the entire machine. It applies to all machines, but it's industrial controls, and that's a type B standard. A B2 would be ISO 13850, the construction of an emergency stop, for example. That would be a B2 type of standard. The last group is a type C, which is specific to a machinery type, industry, or group. So robotics, ANSI RIA 1506. It's the robotics industry. That group came together to form specific criteria as it relates to robots and robot cells. That's a type C standard. When we look at priorities, the priorities on equipment would be type C takes precedence over type B or type A. And it sounds a little reverse because you think A, B, C, A comes first. C always comes first. It takes priority, and then it's backfilled in by the B or C standard. So if you don't have a specific machine standard, such as the robotics industry, you will fall back on the general principles of machine guarding, ISO 14120 for machine guards, construction and design of separating type of guarding, or safety distances, ISO 13855 for calculating safety distance when using presence sensing devices. But when we come back to our core of our governing body, here's an example of OSHA. Many governing bodies have general duty clauses when we look at this. So when you see the general duty clause in OSHA, there are responsibilities on the employer and there are responsibilities on the employee. Bottom line is each employer shall furnish a place of employment which are free from recognized hazards that can cause death or serious injury. It's basically saying that if there's something there that can seriously hurt somebody, you need to protect your people from that happening, from getting serious harm. It doesn't take responsibility away from the employee as well, because the employee needs to comply with what safety and health standards are put into place. There are going to be procedures, policies, PPE. They need to follow that. If that's what has been determined that needs to be done, they're required to follow that under this general duty clause. So it is going back to that team effort. If we break down some of the general standards, such as 1910.212, for example, in section A1 and then A3 subset 2, you can see some of the paragraphs here, and you can go ahead and read those, but in these paragraphs you can see something a little bit more specific in them. What that is in the A1, one or more methods of machine guarding shall be provided to protect the operator and other employees in the machine area from hazards. They go over the types of guarding, but it really comes down to whether it's a hard guard or light curtain, the goal is to protect the operator and any other employee that is in that area from serious harm. The next section, you can see the point of operation machines who operation exposed employee injuries shall be guarded. The guarding device shall be in conformity with any appropriate standard therefore. Meaning, if you're going to use a light curtain or a guard with an interlock switch, OSHA doesn't have specific standards related around components or ways of doing it, but they're telling you there are standards out there that you should be using, such as the industry consensus standards on designing effective machine safeguarding solutions. Now with that, I'm going to go into a couple different types of standards. But what you're going to see is some similarities. So regardless of the standards that you use, you're going to find a lot of similarities in exchange of ideas, thoughts, and information from one standard to another. If you're in the U.S., ANSI is one of our regulating industry, I shouldn't say regulating, I apologize, our industry consensus type of groups that form very good machine safeguarding standards. In this case, I pulled up B11.19. Also, I pulled up an ISO standard, 1420, and then sometimes the manufacturer's installation instructions. So B11.19 is general requirements for machine tools. ISO 14120 is a standard for the design and construction of fixed and movable guards. Or the devices you're selecting, such as safety switch, you see some of the criteria there. But if I highlight some of these areas, what you'll see is some commonality. One of those is the unauthorized adjustment or circumvention of safety devices. Tools are necessary for their adjustment or removal. Types of fasteners that should not be used. Now you go down to ISO 14120, removable only by tool. Use of a tool by an authorized person. Manufacturer's installation instructions. Permanently fitted. Tamper-proof screws. Why do I bring this up? It's because one of the things that you tend to see out there, and you see that bottom statement, guards shall use hardware that requires a tool that is not common to an operator. Where do you read that in the standards? Where do those words come from? You can see some of the generalizations that are made up here. An operator should not have any access to remove any safety devices from a machine unless it's a movable guard that has the proper interlock switches and the control circuitry behind it. Why? An operator can take a coin out of their pocket and remove a slotted head screw. They can pull a pocket knife out that has a flathead or a Phillips head type of bit in the pocket knife. And one of the arguments that comes out, well, isn't that willful intent because they took a tool to remove it? No, because you did not make it difficult to defeat. Here you can see in the standards requiring either a special tool or authorized personnel. Well, who do you authorize? Well, if you make it a common tool that anybody has access to, you've authorized everybody. Who's allowed to remove guards? It could be maintenance mechanics. It could be engineers. It could be setup personnel. So you have to look at that individually in your organization. The next one that we tend to see is the use of machine safeguarding with the interlock switches or a light curtain. So reclosing a guard must not allow the machine to automatically restart. Well, why not? I can close the door. Why can't it automatically restart? Here again, I bring you three different standards, B11.19, NFPA 79, and European EN 60204. Where does it say that? So if we highlight those sections, it's pretty clear when you dig into the actual words, reclosing the interlock guard shall not, in or of itself, cause a hazardous situation. NFPA 79 shall not initiate machine motion or operation that results in a hazardous condition. European, the reclosing of resetting of an interlock safeguarding shall not initiate hazardous machine operations. Here we are with three different standards, but they're basically all saying the same thing. Sometimes it's a little hard reading the words, but if you just drill down to the words, it's not as difficult when you're looking at a larger paragraph, but if you take small bits, you'll see some of the commonality and how you would really apply it to machine equipment. If we look at things such as risk assessment, I've seen cases where people start throwing guards on machines because they know they have hazards, but how do you do that without actually doing a risk analysis? And sometimes, well, why do I need to do a risk analysis? I see that the machine can bite me. Well, you really need to know what the hazards are, and you got to document it. You need to document what you're doing, why you're doing it, how you're doing it. So when you look at some of these standards and you see where it's highlighted, the robotic standards, doing a hazard analysis, a risk assessment, ISO 12100, risk assessment and risk reduction, B1119, risk assessments, 13849, risk reduction. It's all going through that analysis stage and figuring out what you need to do and how you need to do it. The thing you're going to look at is looking at the different standards and seeing that commonality and the statement we have on the bottom. How do you design an effective guarding solution without the risk analysis? Do you know all the hazard points are on the machine? Do you know what access points are needed? How do you do that without doing a full risk analysis versus just throwing a solution in there that may or may not work? Identify what it is, document it, and when you do your risk analysis and you do your implementation, then you can document what you did, why you did it, how you did it. That way, if anything ever comes up as far as questions, you have that documentation backing you up on what you did, why, and how. When we look at controls, you can start throwing guards, whether it's point of operation, whether it's perimeter type of guards. You have to look at the wiring behind it, the hydraulics, the pneumatics. You cannot have effective guarding without looking at what the needs are, especially when you're talking hazards that can cause serious harm. So if we look at some of the control standards, NFPA 79, industrial controls, 13849 for performance levels, safety-related parts of the control system, or ANSI B11.19. When we highlight some of those statements, NFPA 79, complete redundancy or diversity, looking at control reliability that you see in the ANSI standards. 13849, a single fault in any of these parts does not lead to the loss of a safety system when you're designing a Category 3 system, getting redundancy and monitoring. So looking at it, and B1119, the prevent initiation until the failure has been corrected. What this is all telling you is looking at the controls, what is the hazard, what is the level required, because what happens behind the scenes is completely invisible to the operator. What safety controllers do you need in there? What is the wiring? What are the pneumatic safety devices that you need to throw on to make sure that your machine still shuts down and prevents it from restarting so you don't get into a serious hazard condition? There's a lot out there. We know there's a lot of different standards out there. There's a lot of different ways of looking at things, but you can see with the variation of the different standards we just highlighted in the past few slides that we're at a point where there's a lot of similarity in these standards across the country, that we're starting to see more of the ISO type of standards take in effect in all the other industry consensus standards, because it's a conglomeration of everybody working together to find some of the best solutions and the best way to do it. So at this point, I'm going to open it back up to Sandy for any questions that we may have.
Thank you very much, Mike. Great presentation. And a few folks have already submitted questions, and we will get to those in just a minute or two. While Mike is answering your questions, please take a moment to answer the feedback form that will appear on your screen. If you don't see the form, please click the red survey button at the bottom of your screen. And now heading right into some questions. First question, where can I obtain an example of a risk assessment?
Well, risk assessments, actual examples could vary depending on the standard or the industry you're in. You can create your own on an Excel spreadsheet. There are companies that sell software packages that you can see examples out of that. But even the basic core of standards, where you can look at ISO 12100 is a great standard that gives you some of the processes and the hazards to look at in standards. The robotics industry, the RIA 1506, will give you an example of a sheet of looking at risk analysis, or PMMI, the ANSI B155 for PMMI has, I believe, an example in there. So there's definitely examples out there. A lot of times with risk analysis, the people hear risk analysis and they overthink it. It doesn't matter the format that you follow. You can come up with a numbering sequence to identify the risk and the factors. You're typically looking at severity of harm, frequency of exposure, possibility of avoiding it, and sometimes the number of people associated with it. And assigning a value, whether it's a block value, a fixed number, you add or you multiply it. It doesn't matter the sequence that you come up with, or if you use something that somebody's already come up with. It's just the concept behind the risk analysis, which is why you can create your very own on your Excel spreadsheet, is using a resource like ISO 12100 of all the different hazard types, identifying it, marking it down, and figuring out what you need to do. It's just a systematic way of figuring out all the hazards and what needs to be done to fix those. So there's different sources. There's nothing specific I can say, go to this website, but you can refer back to some of those standards I just mentioned.
Okay. Next question, and this is probably fairly common out there. We have pump configurations designed over 30 years ago where guards around high-speed rotating journals are not fully covered. Is it okay to make changes to the manufacturer's guard or shrouds in an effort to prevent contact?
It is absolutely okay to do that. reality is, especially when you look at, when we talk the hierarchy, governing bodies, OSHA regulates. OSHA is not regulating the OEM of the equipment. OSHA is regulating the owner of the equipment. You own those pumps. You own those guards. It's your responsibility that if you see that there's a hazard there, you can do what you need to do to cover those hazards. If there's considerations that you want to include the OEM, to say this is what we want to do, whether you use the OEM to develop those guards for you, or maybe they have a guarding package as an upgrade, because 30, 40 years ago, these principles weren't in place. I mean, OSHA didn't come into an effect until the OSHA Act of 1970. So, 40 years ago, there was no standards. You may not have had machine guarding standards for that particular machine or pump, for example, but you can go ahead and effectively guard them if you're concerned about heat dissipation. Look at your guarding design. But yes, it's a hazard. You're responsible for it. You need to protect your people from getting hurt. You have to implement the proper guard. Now, I know it was for older equipment, but I think this also addresses newer equipment, that there's a concern of breaking warranty on the equipment. Well, if the equipment's not meeting a safe condition to begin with, you have to look internally to figure out what the best solution is, whether it's going back to the OEM so the OEM does the modification and keeps it under warranty, or you're more concerned with the safety of the equipment than you are the warranty. You have to make what's the best internal decision for you, but the bottom line is if there's a hazard that can cause serious harm, you need to guard it.
Okay. Where can I find specific dimensions on size of an opening, height, and width to a pinch point for guarding design?
You have if you look at the OSHA standard, the one place I know there's a chart in 29 CFR 1910.217, which is power presses, but something that gives you a lot more detail as an industry consensus standard is ISO 13857. That's ISO 13857. And 13857 and 13855 kind of go hand in hand. 13857 is minimum safe distance based off of reaching capability. So whether it's reaching through an opening size or reaching over or under guards with your limbs, upper and lower limbs, they'll have different charts based off of the height of the guard, the risk of the hazard, and they have those different dimensions on how far a guard really needs to be based off of opening size, and they're more current, the more up to date for the average worker that's in today's global workforce. ISO 13855, I said, kind of goes hand in hand because that is a calculation. 13857 is good to use with hard guards, fixed guards, where you have fencing or hard barriers that physically stops you. When you use devices that are light curtains, safety mats, laser scanners, two-hand control, they're all what's referred to as non-separating guarding because they don't physically stop you. ISO 13855 gives you safety calculations based off of those different devices and how they're used, based on stop time of the machine because it doesn't physically stop you. So you use 13857 for hard guards, 13855 for presence sensing type of guarding. Okay.
Is ISO 13849 mandatory at this point in time?
It's mandatory depending on where you're at. So if you're talking European equipment and to meet the CE directives, ISO 13849 has replaced EN 954 for industrial control guarding for control categories and performance levels. When you look at the U.S., it's an industry consensus standard. It's an ISO, which is international, and the U.S. participates in that. It's not incorporated into reference into law for OSHA. OSHA is not looking at ISO 13849 as a standard that they're going in and citing people that you're not following ISO 13849. Reality is, in the U.S., we're more of a litigation type of society, that it's more the lawsuits because if it's proven that you know of better principles and practices in machine safeguarding that you should be implementing, such as ISO 13849, because it is an advancement in the thought process of machine safeguarding, of things that they've learned over the decades with the different devices, that should you be using it? Yes, you should be using industry consensus standard, but OSHA does not mandate that you have to use ISO 13849 or NFPA 79 or ANSI B11.19. If you can classify yourself as being called on the industry consensus standards, OSHA says you should be using industry consensus standards. They don't cite you for not using it. It's really playing the gamble of whether it gets bit by a lawsuit, or really looking at it on a company level saying these are the standards that really fit our equipment. We should be using this and protecting our people and implementing standards like ISO 13849.
When you've listed a number of standards in the presentation, and you just listed a number in the answer to the last question, do you have a larger summary of the standards that would serve as a good first group to go to?
I personally don't have a specific list. In some of manufacturers' catalogs, like our catalogs of products, we'll have a section that lists some of the common core standards. But you may be able to find some things on the websites, but the ones that we see in the PowerPoint are definitely some of them. In addition to that, there are some additional ISO standards. We mentioned 14120, 14121, 13855, 13857. They're all core generic Type B standards that are good to use and implement in machine safeguarding concepts. So we don't have one full compiled list of all the basic generic standards. It really depends. As it comes up and you gain more experience with it, you know what standards to go with.
Okay. When building a machine or system where a robot is used, does the IRA risk assessment supersede the ANSI B11 and ISO 13849 risk assessments, or are they still required?
It really depends on you. First is, because it's a robot, it's the ANSI RIA 1506 is the Type C standard. That standard takes precedence over anything else. So if you're following ISO 13849 for identifying your safety function, you may go through the decision tree and say, I need to be performance level D, for example. But when you look at that robot standard says, I don't care what you came up with, this needs to be performance level E or C or whatever it is. You're following the robot standard because that is industry specific. So the hard part is just balancing the two out. You definitely do what the Type C standard says, but there's nothing wrong where if the Type C standard says it has to be performance level C, but you say, you know what, based off of how we're using it, we need to make this performance level D, you can always take it higher based off of using those other standards. You just do not want to take it lower than the Type C standard because that will come back and bite you.
Okay. Some people seem to think that older machines only need to meet safety standards from the time those machines were built. I don't think this is true, but I have customers insisting they need to apply standards from 1999 for machines built before 2006 for Europe.
Well, the reality is, when it comes to machine safety, there is no such thing as grandfathering. When you look at a lot of the standards, and I'll pick ANSI as an example, you open up just about any ANSI standard, you'll actually see in some of the preliminary information that they give you a time for conforming. Any new equipment must conform right away. Any existing equipment, they may give you a window of 24 months or 36 months to bring the old equipment up to that current specification. And the reason behind that is, at the time the machine was built in the original standards, they may not have had the technology to have effective guarding for that machine. And that's why you see standards always evolving, and you see new revisions or versions coming out every 3 to 5 years on average, because they've learned things. They have experience from manufacturers as well as the end users of the equipment that have improved the process and come up with newer solutions and newer technologies. So just because a machine may have been built to safety standards 20 years ago doesn't mean it's current on today's safety standards, which is why you should always be doing risk assessment every so often, whether it's every year, every 2 years, something to identify, is this a machine current? Do we need to improve it and make those improvements if required?
Well, thank you very much, Mike, and that concludes today's presentation. On behalf of EHS Today, Machine Design and New Equipment Digest, I'd like to thank everyone for joining us. Thanks to Mike for his great presentation, and thank you to Schmersal for sponsoring this event for us today. I hope that everyone has a productive and safe remainder of the day. Thank you very much.
Thank you.